Welcome back to the shop, guys. Today we are going to be 3D scanning a 3rd gen Ford Raptor. This is for our new battery tray system, more or less. Now the whole point of this is essentially to create a solid place to mount all of your aftermarket electronics. These trucks are awesome. The Raptors come with upfitters and that's great for a lot of stuff. However, all of us know that we can't power our high power light arrays or light bars, stuff like that, with those smaller amperage systems like the factory upfitters. So we use systems like S-Pods and Garmin PowerSwitches to help control all of that. We just need somewhere solid to mount them. We don't like that everybody's over here screwing them into the top of fuse boxes and mounting them in random places. So we're coming up with a solution for that, just like we have with the Toyota market. So with these, Ford created this massive plastic bulky battery tray for these trucks that, if you look under your hood, takes up way more room than it needs to. So we're gonna go ahead and eliminate that system altogether and create a drop-in tray system that will house your battery, your switching system, potentially mount locations for dual battery systems such as Redarcs, solar input for Cascadia 4x4 solar hood stuff, so that you have solid mounting points for all of these problems or electrical solutions that we have. So let's go ahead and dive into it. We're gonna start by spraying. We use the AE Sub Scan Spray. We're gonna start by spraying all this. This stuff evaporates in a matter of like a couple of hours. It is temperature based, so gonna go ahead and spray all this. So when it's colder out, it lasts longer. When it's hotter, it evaporates faster. Getting everything that's in the area over here so that we make sure we know where everything's at. All right, so now that the whole thing is sprayed and everything's cured white, we can go ahead and start scanning. The reason that's important is it provides a very uniform texture and color for the scanner to pick up on. Some scanners don't need spray. This one doesn't always need it, but with such a variety of colors and textures right here between the like felt style backside of the wheel well, the shiny metal, the more matte plastic, we found that it's a lot more reliable of a scan if we just go ahead and spray the whole thing anyways. So it's worth the $40 a can or whatever it is to us to go ahead and get as accurate of a scan as possible the first time around. So from here, we're gonna go ahead and grab our scanner. So we've got everything set up here, so you can adjust the brightness and all that. There's a ton of settings for this thing that I don't even necessarily know yet. So as you can see, we're in preview right now. Everything's working great. It's trying to find where it was previously scanned. So you can see it lining up. The green is the new scan, the blue is the existing. So we'll go ahead and start scanning here. And so now it'll start adding that scan as we scan our way through the engine bay, picking up new objects, new angles. You work your way back and forth, going at different angles, making sure that you get a full image of this thing, because obviously the scanner is working off of what it can see. So for example, you can only see one side of a part. So like if we come over here, say I were try to scan this guy, right? If I scan it from this way, I won't be picking up what's on the other side of it. And it can actually block my scan as well. So you just want to move your way around as much as you can, get as many angles as you can of the whole thing to give it the best field of view possible for what's going on under the hood of this truck. that should give us a pretty solid image of what's going on in this area. Oh yeah, so we've got all of our mounting holes here. That's the bracket that we'll generate as the base tray for our, or the base bracket for our new tray. We've got mounting positions here and here, as well as bolt holes back here where the factory tray was bolted in. So the factory tray was mounted right here, and then back here as well, along with the holes along the bottom right here. So we've got all those holes marked. As you can see, with using the scanning spray, we don't need to use the dots at all. A lot of scanners use these guys here, little reflective dots of various types, but little reflective dots like that, and that'll help track stuff. But with something as complex as an engine bay where you have tons of stuff going on, the scanner really has a pretty easy time keeping track of where it is. Stuff like a roof line, for example, like our friends up at Sherpa, I kind of feel bad for them because they really struggled with 3D scanning roofs until, of course, their new scanner. But a lot of that was to do with there's nothing to track. When you're looking at a square this big, you can't tell where you are in the world. But if you look at a square that big and you have all these holes and shapes and wires going on, it's easy to keep track of. So this guy looks good. We're gonna go ahead and export this, throw it into Autodesk Inventor, which is our CAD software of choice, design a new bracket system. All right guys, so from here, we're gonna go ahead and generate the point cloud that's stopping the scan. Yes, we could go back and add to it later if we wanted to. However, from here, the computer's gonna go ahead and generate the point cloud for us, and we'll take that and export it. What's amazing is how powerful of a computer this is and how long it still takes with these probably a couple million points that it's scanned, that's picked up on. Now that we have the point cloud generated, the scan saved, we went back over to the mesh model. We're gonna go over here and select some options to filter stuff out, smooth stuff out, and remove floating parts. The floating parts are the stuff that's out here in the middle of nowhere. But, like I said, it only has a viewfinder of that big. It sees this much of the world. And so if it doesn't see how this part's connected to something, it's not picking up on that data. So all this stuff that's out in the background that just kind of got scanned, it will go ahead and remove for us as well. It's gonna set a max number of triangles, so that's the maximum number of, so the mesh is based off of triangles, so thousands or hundreds of thousands in this case of little triangles generate the object. Fill small holes. We're not gonna do that because we're looking for small bolt holes, so I remove that, and then we're gonna go ahead and apply that. It's gonna go through, simplify the model for us, remove a lot of that extra stuff around the edges, and give us a much more usable model. Also, these scans are massive when it comes to file size. There's so much data in these things, and that's why it takes so long to process. So look right there, it got rid of quite a bit for us. So we're left with, we gotta always check our key features. We wanna make sure there's nothing that we need in these areas, which in this case there's not. There's a harness that runs right there that is easily moved out of the way, and it's sitting so far over that it doesn't affect our design at all anyways. We have our bolt holes here, none of them got removed or deleted. We have our hole up here. It removed the strut, but that's fine, we don't need it anyways. And then we have our hole here. So we have the main pieces that we're looking for. We got the edges of the entire inner fender here, along with the fuse box and some room for wires. So that'll give us a super solid foundation to go ahead and mock up a battery design and then get a prototype ordered in. So we're gonna go ahead and confirm those changes, and this is what we're left with. From there, we save the scan. This is the scaling, which we don't need to do. We have to scale it when we move it in. So these are all done in millimeters, these scans are. We obviously work in inches. So with that, it's just a simple conversion that we do when we import the file into Autodesk Inventor. Now we're done. So I'll save that guy onto the server here at the shop and then pull it from the CAD computer in my office and start working on that design. I'm editing the video right now, guys, and realized I didn't make an outro saying goodbye to you. So thanks for following along. Stick around for a few extra seconds if you want to see a little bit more of a close-up and in detail of what that scan looks like immediately after the scan, while we're still in that shining 3D software that our scanner uses. Thanks for checking the video out. Like, comment, subscribe, whatever. Go follow us on Instagram. Definitely check out the new Blaze website. I've been working on this thing for months now. It's probably been, I guess 6 months total we've been on the platform, but 3 or 4 months I've really been hammering away at the site. We're getting new product loaded, relaying stuff out, writing articles. Check out the news and how-tos. Head over to the website. Thanks for checking the video out. Stick around for that 3D model.